Okay, welcome back for another video to do with quadratics. What we're going to be looking at in this video is the idea of what we call solving a quadratic equation. And you might read various different terms that are all basically referring to this process. So there's three terms here. You might be asked to find the solutions or solve the quadratic equation. You might be asked to find the x-intercepts, which is something we've already done quite a bit. Or you might be asked to find the roots of the equation, and you might remember we all had a giggle at the graphics calculator that had a function on it called root. These three terms here all mean the same thing. Okay? So anytime you see any of those three terms, they're all talking about the same thing, which is really the key question is, which x values make y equals 0? So we're just interested in what x values can go into a quadratic equation to make y equal to 0. And there's a few possibilities with that. As you guys know, if we look at the graph of a quadratic equation, there's a few possibilities in terms of how many solutions there might be. So if we look at our typical parabola, it might cross over the x-axis twice. In this case, we would say that there are two solutions to that quadratic, or two x-intercepts, or two roots. Either way, there are two x values that will make y equal to 0 in this case. There's another possibility too. Let's get the right color. The second possibility is that the quadratic comes along and just touches the x-axis. Okay? And you might recall this from when we were sketching quadratics. In this case, we would say that there's only one solution. There's only one x value that will cause y to be 0. And again, we could say one solution or one x-intercept or one root. It doesn't matter. In this case, there's one x value that makes y equal to 0. And of course, there's a third possibility. Whoa. Okay, I'm sure you guys will draw this a lot neater than me. The third possibility is that our quadratic comes along and never actually touches the x-axis. And that's quite possible. That happens all the time. In this case, as you can probably guess, we say that there are 0 solutions, or 0 x-intercepts, or 0 roots. There are no x values that make y equal to 0. It just doesn't happen. So that's the three possibilities. Okay, let's look at some examples now of how we can use what we already know to find the solutions to quadratic equations. So the first example that I want to look at is finding the solutions using the factorized form, or by factorizing. So I'm just going to write here, e.g. by factorizing. Now, I'm not going to take you through the process of factorizing a quadratic because I'm assuming that you can already do that from our previous videos and work. So I'm just going to start with the factorized form. So let's say I've got a quadratic and I've done my factorization process, and it looks like this: y equals 2x plus 1 in brackets multiplied by x take 5 in brackets. Okay, and we want to solve this. If we're going to solve it, so I'm just going to write solve. That means that y equals 0. We're trying to figure out what x values make y equal to 0. So whatever this equation comes out to, it gives us our y value, which we know is 0. So I'm just going to set that equation equal to 0. Now, in this case, there's two possibilities that could cause this whole equation to come out to 0. The first possibility is that this first bracket equals 0. The second possibility is that this second bracket comes out to 0. Because if we were to imagine, let's say, some number a times some number b equals 0, there's really two possibilities here. Either a equals 0 or b equals 0. And it's the same here. We've got something in brackets times by something in brackets equals 0. The only two possibilities are either the first bracket equals 0 or the second one equals 0. So if I take that on and look at my two possibilities, if 2x plus 1 equals 0, we can figure out what x is by a bit of rearranging. So take the plus 1 over to the other side and it becomes negative. And then divide both sides by 2, so x equals negative a half. Or the other possibility is that x take 5 equals 0, in which case we just add 5 to both sides, x equals 5. So the two solutions, or x-intercepts, or roots, whichever one you want to call it, are x equals negative a half. Actually, I shouldn't write and. That's probably not 100% accurate. I should write... Sorry, I shouldn't write or, I should write and. The solutions are x equals negative a half and x equals 5. So if you were to draw that graph, you know that they would be the x-intercepts. Okay, let's have another example in a tick. Okay, another example by factorizing again. Let's say we've got something like y equals x take 5 all squared. In this case, there's only one possibility. So, well, okay, let's just do our first thing. We need to set it all to 0 because remember we're interested in what x values make y equal to 0. So we're going to say x take 5 in brackets all squared equals 0. The only possibility here to make all of this 0 is that this thing inside of the brackets, whatever it may be, is equal to 0. So easy done this time. I won't jump, I'm going to tick. In this case, x take 5 has to equal 0, so x has to equal 5. The reason that's really easy. The reason I want to show you that is that this is an example of where there's only one solution. So that would be an example where if you plotted that and went to x equals 5, that would be the only point that the quadratic touches the x-axis. Okay, I'll just pause again and move on. Alright, so the other way that we can find the solutions, or the x-intercepts, or the roots, is by completing the square. So you remember from our last video, completing the square is that tricky little process where we convert the equation from a regular quadratic into a quadratic in vertex form. So we can also use vertex form to solve the quadratic equation. Let's do an example. So I'm going to say now y equals x take 5 all squared take 2. So I'm interested again in which x values make y equal to 0. So that means that this entire equation must be giving us 0. Now I'm just going to rearrange it. So this negative 2 can go over the other side, become a positive 2. So I know that x take 5 all squared equals 2. Remember our little trick for getting rid of squared is to square root both sides. So if I take the square root of both sides, I get left with x take 5 on one side and the square root of 2 on the other. I'm just going to write it as root 2. But it's important here that I have to say that this could be positive or negative. And that's because we know that, let's say we're talking about something easy like the square root of 4. We know that that's plus or minus 2 because 2 times 2 equals 4, but also negative 2 times negative 2 also equals positive 4. So anytime I take a square root, I have to give the positive and the negative answer. So I need to put a plus minus out the front. And that can just stay there for now. The last step is to get rid of the negative 5 so that I've got x by itself. So I'm going to add 5 to the other side and keep my plus minus there. So x equals 5 plus or minus root 2. So my solutions are x equals 5 plus root 2 and x equals 5 take root 2. Notice that I haven't gotten my calculator out and figured out the decimal version of this. I'm happy for you guys just to leave it in the square root form because that shows me that you've understood the process, okay? So you don't need to immediately jump to your calculator, especially because if you plug in square root of 2 into your calculator, it will only give you the positive answer. But that's only one of the answers. There's actually 2 solutions here, so you really need to be careful that you include the positive and the negative version of the square root, okay? All right, I'm going to do one more little example just to show you something. The last thing I wanted to show you was also using completing the square, but on a slightly different equation. So let's say we're looking at x plus 3 squared plus 10. So this is in vertex form again. If I want to get the solutions, I need to make that equal to 0. So I'm going to say x plus 3 squared plus 10 equals 0, which means that x plus 3 all squared equals negative 10 because I've subtracted 10 from both sides. Now, I can take the square root, but I'm going to run into problems because as soon as I go x plus 3 equals square root of negative 10, we can't take the square root of a negative number and get a real answer. We can get an imaginary answer, which is a concept for another day, but we know that we can't take the square root of a negative number. If you put that into your calculator, you'll get an error. And that's because you can't take the square root of a negative number. So in this case, there are 0 solutions. And so that means that if we sketch the graph, and in fact we can do that pretty easily because we know that the vertex is, in this case, going to be negative 3, 10, which is somewhere around here. If we sketch that graph, this is a positive graph because there's a positive sign out the front. It's going to look something like that, and that makes sense. There's 0 solutions because that graph never crosses the x-axis, so there's not going to be any x-intercepts. So I just wanted to show you that just to illustrate that sometimes when you try to find the solutions, you're not going to get any. And that's okay. That still tells us something about the graph. Okay, that's it for today. Thanks for watching.